Now we're going to make this image into a halftone image. If you missed my video on making a bitmap image, you can find that under my channel. First thing we need to do is remove all of the color from the image by going to image mode and changing it to grayscale. And we'll discard the color. Our next step is to go to image mode again and move it into bitmap mode. In bitmap mode, we have input resolution and output resolution. We have to be concerned about output resolution for screen printing because a small enough dot will either not print or not be supported by the fabric. So we need a certain size dot. In my bitmap video, I talked about the resolution for bitmap is 100 pixels per inch. We have actually two resolutions that we have to be concerned about with bitmap images. If we look at this image up close, we can see again that it is made of pixels from black to white and several grays, 256 grays in this case. We need to make every pixel either black or white. In creating a bitmap image, we are making each pixel either black or white. In a halftone image, we are trying to create dots or shapes that are still made of pixels. A halftone is a way of creating grays with black and white for photo-based images. It can be dots or ellipses or lines or any number of shapes. Halftone shapes are made of pixels. Here you can see a round dot printed at 300 dpi. This is made of actually 300 pixels per inch to create the smooth edges of that shape. When we lower the resolution of the image to 72, we see those sharp edges now have sawtooths or are jagged or are pixelated. And when we lower it even further, we see now we no longer see a very round dot. We see a very jagged shape that's created out of a series of small squares, i.e. our pixels. Right? So we have two different types of resolution when we're trying to create a halftone. We have the pixels per inch, or the PPI, and they've got it labeled DPI here, but it's really PPI that we're looking at, pixels per inch. And so we need a high number of pixels per inch to create smooth edges for our second type of resolution, which is our LPI, or our lines per inch, for our halftone shapes. Halftones are expressed in lines per inch. That is, they are arranged in a grid or a pattern along a line. The line could be horizontal, could be vertical, or could be at an angle. Here we see them simply vertical, and we can see resolution for a halftone dot. Here our halftone shapes at 10 lines per inch are much larger in general than our halftone shapes that are 20 lines per inch. So two different types of resolution. We have pixel resolution, which is PPI, and then we have halftone resolution, which is LPI. So let's make this image into a halftone. We'll go to image mode again, bitmap, and now we want to input a higher number for our output resolution, higher than even 300 in my experience. I'm going to make this anywhere between 600 to 800 pixels per inch. So I want tiny pixels here, making up the image. My method is halftone screen. Once I select OK, I get this second dialog box. Now we're selecting the resolution for the halftone screen. Right? We have three things that we can change in this dialog box. The frequency, which is our resolution, that's our lines per inch. That number for our screen mesh, which is 195 lines per inch, needs to be 30 lines per inch or under. As a general rule, the smaller the number, the bigger the dot, the more predictable the stencil will print. So if we have a 30 line per inch dot image and I print that, those dots are as small as I can possibly get. That could have a tendency of bleeding depending on the size of the print. So if I'm printing a small print, say 8 by 10, it may not bleed much at all. But if I'm printing a large print, I have to exert more pressure on the squeegee, which can mean that the image can have a tendency to bleed. If I print a larger dot, say 20 lines per inch, that will give me a more predictable result regardless of size. In my experience, halftone stencils are very different than any other kind of stencil. Right? Minor changes in pressure and in printing and in inking and so on, flooding, can make a big difference in what the image comes out like. Now, we're not always concerned with strict reproduction, but if you want accuracy in terms of I want my print to look exactly like the stencil, then the larger the dot, the better. And I would say 20 is a good starting place. So I'll leave it there. Angle, of course, is our lines per inch and what direction they are moving. This is the angle, right? This would be expressed as probably 90 degrees. So as I choose my angle, a standard angle for a single halftone generally is around 45 degrees. So I'm going to leave it there. But in some cases, I may want it a different angle. Say if I'm using a line instead of a round dot, right? Maybe I want lines to be horizontal, in which case I would choose a degree that would make the lines horizontal. So now we have 20 lines per inch, 45 degree angle, and we have a round shape. You can see we've got 2, 4, 6 that we can choose from. In our print lab, in the computer room, we have examples of all of these shapes printed out as the same image. So you can see one image in these 6 different shapes, as well as one image with different size lines per inch. I'm going to choose round. As a general rule, ellipse as a shape works best for screen printing, just because of the mesh that the halftones are going to be going on, but you can really choose any shape. So I'll leave this round. It's kind of a common standard shape. We'll say OK. And now you can see our image has been turned into a halftone image. This kind of visually looks like a 20th century mark, right? It looks like magazine or newspaper or billboard kind of printed images. Bitmap images look almost like an inkjet or a very rough inkjet print. So where a halftone dot is a 20th century kind of mark, a bitmap or a pixel-based image may look more like a 21st century kind of mark. If we zoom in on this, we can see our dots are fairly smooth. I mean, we're looking at it at 200 degrees magnification, so we are seeing pixelization when we zoom way in, but our pixels are very, very small. So to our eye, when we look at this at 100%, they look fairly smooth, right? I'm going to undo this a second. And I'm going to do this again. We're going to go to image bitmap, leave it at 800, halftone screen. And this time I'm going to choose a different shape. I'm going to choose a line. And I want my line to go horizontal. So I'm going to put in 0 degrees, and that will change the angle of the line. There we go. Image is now, instead of being made up of round dots, is made up of lines. And those lines are horizontal. I'll undo this one more time, and I'm going to show you what our dots look like if they are a lower resolution. So if I leave this at 100 pixels per inch and I say OK to this, and I change this back to a round dot, and I change this to 45 degrees, we say OK. The image looks smaller here. As I zoom in, here is the image at about 100%, right? Physically, it looks very pixelated. The best way to see this is to print out each of these. You can see these don't even look like dots, right? Because the pixels are much larger than we'd want them to be. So, to summarize, our important aspects here are we need to understand we need a higher resolution for our output resolution under image mode bitmap. We need a higher resolution for output for our halftone screen. And we want to generally use 30 lines per inch or under. And that the smaller the number here, the more predictable our stencils will print.